In this section of 1.1, we'll be taking a look at real numbers. And real numbers are any number that you can think of. All of the numbers that you have ever experienced in your life, I would be willing to bet, are real numbers. Have you ever used a calculator? Every number you can get on a calculator is a real number. Okay, let's take a look at different types of numbers. So the real numbers encompass everything that you know, but then we have some further definitions, some divisions. And they would be, so we see that real numbers, and you'll notice we use that kind of fancy R to stand for real numbers because mathematicians are too lazy to write out the words real numbers. So real number is every number you can think of, and there are some examples. A +3, a -7, 2/3, a fraction, 1.57, a decimal, pi, which is a number that never repeats. It's a decimal that never repeats and never stops, and the square root of 2, that's likewise, it never repeats itself and it never stops. So within this set of real numbers, we have natural numbers. What were the first numbers that you were aware of as a child? What did you first use numbers for? Counting. So the natural numbers are the numbers, we lost that. Let's get back to, sorry. Oh, you get a preview of what's coming. That's probably not a bad idea. There we go. Okay, so we're here at natural numbers. What did you first use numbers for? Yeah, for counting. So the set of natural numbers are just the numbers 1, 2, 3, and so forth. The numbers that you use for counting. Whole numbers are like natural numbers, except for only one more number. The most important number in the world, 0. So whole numbers are 0 and all of the natural numbers. And we go on and on and on. The set of integers, well, maybe the easiest way to describe a set of integers are the numbers you would normally see on a number line. So we would see 0, we would see 1, 2, 3, and so forth. And then over to the left, we would see a -1, -2, -3, and so forth. So the integers are those nice numbers, both positive, negative, and 0 that we would see on a number line. And we indicate that with ... to indicate that goes on forever in that direction. 0, 1, 2, 3, and ... Okay, now the last two are an either or. A number is either rational or it is irrational. And we can't list the rational numbers like we have been able to do so far. So the rational numbers, let's define it, is a rational number is any number which, and I'm going to emphasize this, can be expressed, let's get that, can be expressed as a fraction. So the key words here are can be expressed as a fraction. It doesn't mean it has to be a fraction, but it can be expressed as a fraction. So for example, I think we need a little bit more examples of there. What about the number 7? It's not a fraction, but can it be expressed as a fraction? Yeah, we can easily change 7 to a fraction by just throwing it over 1. Another example of rational numbers, so let's talk about decimals here. So we have two types of decimals that are rational numbers. They can be expressed as a fraction. The first time is when they stop, and those are called terminating. So for example, up here we've got an example of a terminating decimal, 1.57, it stops. And if we wanted to express that as a fraction, we can say that's 157 over 100. So yeah, we can express that as a fraction. Another type of decimal that can be expressed as a fraction is something called a repeating decimal. An example of that might be 0.3333, and that 33333 goes on forever and ever and ever. And to express that, we call that 0.3 and put a line over it. I'll talk more about that later. You don't need to know that right now. Just know that if something's repeating in the decimal, you can see the pattern. It can be expressed as a fraction, so it's rational. And then if something's not rational, then it's irrational. So an irrational number is anything that can't be expressed as a fraction. For example, pi. We use the estimate 21 over 7 or something like that. No, that's not. 22 over 7 doesn't equal pi exactly. It's just an estimate. So pi is not a terminating decimal and it's not a repeating decimal. 3.1416, blah, 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 blah. It goes on forever. Another example would be square root of 2, square root of 3, square root of 5, and so forth. Okay, let's take a look at a couple examples before we run out of time here. Oh, before we get to the examples, so to put all of this together, if you have your real numbers, the major division of real numbers is between rational or irrational. There is no overlapping there. Within the rational numbers, we have integers, the numbers you see on a number line, and within integers we have the whole numbers, and within the whole numbers you have the natural numbers. Okay, so if a number, let me just point one thing out here. If a number's natural, automatically it's whole, and automatically it's an integer, and automatically it's rational, and every number that we are aware of is real. Okay, and furthermore, if a number's not rational, if it's not in this box, then it can't. Then it's not in. If it's not in this box, then it's certainly not going to be in the integer box or the whole number box or the naturals. Okay, I think we better just stop here because I think I'm going to run out of time, and then we'll take a look at some numbers and decide what's the most we can say about them. Where do those numbers fall? Are they naturals? Are they wholes? Are they integers? Are they rational numbers? They're all going to be real, or are they irrational numbers?